Hello everyone, welcome back. In today's video, we are going to talk about another lead code problem so that you can strengthen your coding skills. So let's take dive into the question. So today we are going to talk about this question 1048 longest string chain. So in this question, we will be given an array of words where each element consists of lowercase English letters. Word A is a predecessor of word B if and only if we can insert exactly one letter anywhere in word A without changing the order of the other characters to make it equal to word B. For example, ABC is a predecessor of ABAC because we can remove one A and we can get ABC. We have to keep in mind the order has to be kept the same. Like CBA is not a predecessor of BCAD, even though if we remove D, we are going to get the same character, which is ABC, but this is not in the same order, so this is not a predecessor of BCAD. CBA is not a predecessor. A word chain is a sequence of words, word A, word 1, word 2, word 3, word 4, up till word K, with K greater than or equal to 1, where word 1 is a predecessor of word 2 is a predecessor of word 3, and so on. A single word is trivially a word chain with K equals 1. We have to return the length of the longest possible word chain with the words chosen from the given list of words. So let's understand the question in a better way by seeing some examples. In this example, words A, B, BA, BCA, BDA, BDCA. So one of the longest word chain is A, BA, BDA, BDCA. Because A, then we can from BA we can remove B and we can get A. From BDA we can remove D and we can get BA. And BDCA we can remove C and we can get BDC, BDA. So we can get a longest chain of four words. Similarly, we can see example 2 and example 3 as well. In example 2, we are going to get 5, and in example 3, there is no predecessor, so only one, which is with output is going to be 1 because the other element is not a predecessor of the previous element. So how are we going to solve this question? So let's straight dive into the solution. So this question is very straightforward if you are taking the right approach. So first of all, we have been given a vector of strings, words. So uh, we are going to sort out these words based on the size of each word. So first of all, we are going to write this sort function, and we are going to give words.begin, comma words.end as the first two pointer because we want to sort the first word till last word, and we are going to give a compare function like to show how we want to sort this function, sort this basically words. So this compare function, as you can see in the top, it's written. We want to sort out this uh, string of vectors based on the size. Like if b dots the like this compare function is going to take two strings as an input because it's a vector of strings. So if the size of the second string is greater, then we are going to sort it out in a ascending order based on the size. So a dot size is less than b dot size. So this is the compare function. So from here till here, we have sorted out our vector of strings in a ascending order based on size. Now we are going to initialize a DP vector with 1 of size n. And we are going to initialize a answer integer, sorry, as 1 because 1 is a minimum word that we can get, like minimum length of the longest chain word, because if there is no predecessor, then one word is going to be our output. So let's dive into the solution. So we are going to solve it using two for loops. The first for loop is iterated from I equal to 0 till I till n. N is the size of the word. And second for loop is iterated from j equal to I plus 1 till n. So in this way, we are basically checking whether first word, whether these two I and j are the predecessor or not. Like this if statement is basically checking if the words I dot size, the first word dot size equal to next word dot size or not. Oh, and is predecessor is basically checking whether these are predecessor. Let's say this is a function which is going to give us true or false if the this current size till the next size, like the next size that we are going to get, first of all, whether that next element is the size of the next element is greater than just by 1 compared to the previous element, and whether this is predecessor function is going to give true or false, whether this is a predecessor or not. We are going to write and talk about that is predecessor function separately. Let's assume that this predecessor function is going to give true or false if that is a predecessor or not. So dpj is going to be maximum, and then we are going to update our dp table, dp array based on dpj equal to maximum of dpj comma dpi plus 1. So this dp table is basically storing the output till now. Basically, like dp value that we have till now, dpj is the maximum of dpi plus 1 comma j. dpi plus 1 is because if we found a predecessor, then the length of the longest chain is going to get increased by 1. If we uh, if you and this value is going to be the maximum of the value that we have initially plus that we are going to take now. Now the thing is like why we are taking dpj equal to maximum of dpj comma dpi plus 1. Why dpj? Why we are not doing dpj equal to dpi plus 1? This is the main question that we are going to discuss now. Let's say we have 2 3 element of size 2 and 2 3 element of size 3. Then in that case we have to decide which element are we going to take of size 2, which element are we going to take from the size 3, because we are going to take only one element from size 1, from size 2 and size 3. So let's say we took the first element from the size 2 and the third element from the size 3, if we have 3 3. In that case, we are going to check which dpj is giving us maximum value, maximum dpj. That if you are taking first 3 or second third or second first, so that's why dpj is equal to dpj maximum dpj comma dpi plus 1. And we are going to update our max answer value based on the maximum answer value that we have till now comma dpj. Dpj is basically like till, let's say by taking, we have a size of the words ranging from 1 to 7, but taking 1 2 3 4 is the elements only, we are getting the maximum answer value, so we don't have to care about third fourth fifth. So that's why answer is going to store about the maximum dp value that we have till the whole operations. And finally we are going to return our answers. So this is our going to be the output of the final of this code. Now let's talk about how to write this is predecessor function. So is predecessor function is basically taking two input as an two input of strings, and first of all we have to check whether these two the string 1 size and string 2 size are going to be differed by only 1 or not. If it's more than 1 or less than 1, then we are going to return false, otherwise we are going to return true. And we have set up a bool jump variable which is false initially. What it means, basically we can jump only once, we can skip only one element in the string 2, and rest both string, after jumping one time, both string 1 and string 2 has to be equal. So that's why this jump variable is basically, jump variable is false initially, that we haven't skipped any element, and once we skip one element, then we are going to set it as true. And then while checking each element one by one, if we got a condition which we need to jump again, then overall, this is not a predecessor. String 2 is not a predecessor of string 1. So this is, we are going to return false in that case. So let's see the for loop now. So for the for loop, first of all, we started iterating from I equal to 0 to the maximum size of the string 2, because string 2 is going to be the predecessor. So it's going to like the bigger than string 1. So it has more element and we have to skip one element from string 2. And we are going to check each element of string 1 and string 2 one by one. And we are going to check whether those values are those character of those strings are equal or not. So this J. So first if statement is basically the character at the J is representing the index of string 1 element, and I is representing the string of S2 element. Then if S2I is equals to S1J and J is less than S1 dot size, we have to make sure that J doesn't go beyond S1 dot size. In that case, we are going to increase the value of J by 1 because we have found element which is equal. So this is satisfying the condition of predecessor and we don't need to jump as such. So we are going to increase the value of J and we are going to start the loop. Like we are going to continue the loop again. If the value of the jump, like if the value of jump is false right now, and those values are not equal, then we are going to jump one time at max that we can jump if those S2I is not equal to S2J. In that case, we are going to jump one time and going to increase, set the value of jump as true, and we are going to continue our loop. Now, if we found this is the condition is shown in the else if statement. If in the else statement, if basically else statement is representing here if the characters at I and J are not equal and jump is also true. In that case, we have to return false because this is not a predecessor of string. And for each of them, we are going to increase the value of J by 1. So this is the is predecessor function, and this is the final overall code of this question for this question. So if you found this video helpful, don't forget to like, subscribe, and drop a comment with your thoughts and question. And keep coding, guys. I'll see you in the next video. Thank you.